Hey, hi all. So once again, welcome to Mathematics Mania YouTube channel. Yeah, so in our previous video, we just found when y is equal to sine of a sine inverse x is given. Then we found to prove 1 minus x square of yn plus 2 minus 2n plus 1 minus n square minus a square into yn equal to 0. And we were supposed to find the nth order differential coefficient of the function yn at x is equal to 0. The meaning of finding the nth order differential coefficient yn at x is equal to 0 means we need to find the value of this function, the nth derivative, the coefficient of the yn when x is equal to 0. So for that, what we will do is we will start differentiating the given function y with respect to x, and then we will make use of whatever we have proved, 1 minus x square into yn plus 2 minus 2n plus 1, and then we will try to find what is the yn of 0. So it's given that y is equal to sine of a sine inverse x. Therefore what happens, y is equal to sine of a sine inverse x is given. So y1 would be equal to sine of something will become cos of a sine inverse x into, we have to apply the chain rule. A into sine inverse x will become a into 1 divided by root of 1 minus x square. So this will be that will be equal to a into cos of a into sine inverse x divided by root of 1 minus x square. So this is our y1. So now what happens, we have to find the y1 of 0. This implies y1 of 0 will be equal to, see, we have to replace the x by 0. So what happens here, a into cos of a sine inverse 0. Sine inverse 0 is nothing but 0 itself. So this will become a into cos 0 divided by root of 1 minus x square. 1 minus 0 is again 0. So that will be a into cos of a into sine inverse 0 is 0, 0 into a is 0, so this will become cos 0 divided by root of 1 minus 0 square. 1 minus 0 square is 0, so that will be equal to a only, because cos 0 is 1. Cos 0 is 1, so this will be implies y1 of 0 will be equal to a itself. Okay, this result, this y1 of 0, we will need to find the yn of 0. Okay, so now we need to find the y2 of 0 also along with this. So what we have, y1 is equal to, we have this one. So what happens, so y1 is equal to a into cos of a sine inverse x, right, divided by root of 1 minus x square we have. So what we will do, okay, so that will be root of 1 minus x square into y1 will be equal to a into cos of a sine inverse x. So this we have already found anyway. Now squaring on both the sides, we will have 1 minus x square into y1 square will be equal to a square into cos square a sine inverse x, right? And cos square x can be written as 1 minus sine square x, because sine square x plus cos square x will be equal to 1. Cos square x will be equal to 1. So cos square x can be written as 1 minus sine square x. So this will become 1 minus x square into y1 square will be equal to a square into, this can be written as 1 minus sine square a sine inverse x, right? Why I wrote this is because we have y is equal to a sine inverse x, so that I can replace this term by y square. That will be easy for me to simplify. So this sine of a sine inverse x, the whole square is nothing but sine square a sine inverse x. So that will become 1 minus x square into y1 square will be equal to a square into 1 minus y is sine of a sine inverse x. So sine square will become 1 minus y square. So now differentiating this with respect to x again, so we will keep it as it is first function. 1 minus x square into derivative of y1 square is 2y1 and derivative of y1 is y2 minus, because the derivative of 1 minus x square is minus 2x, so minus 2x into y1 square will be equal to a square is constant, derivative of 1 minus y square, so that is 0, derivative of 1 is 0, minus derivative of y square is 2y into y1, right? Now if we see here 2y1 is common in all the terms, so what I will do, I will take 2y1 common here, so that will become 1 minus x square into y2 minus, this will become 2y1 I have taken outside, so xy1 will remain here, will be equal to, so here also I will take 2y1 outside. If I take 2y1 outside, so this is 0 minus minus a square y will be remaining inside, so that will become minus a square, and y1 is taken common, so this will become y. So this 2y1 and this 2y1 can be cancelled. Now this minus a square y I will move to this side, so that will become 1 minus x square into y2 minus x y1 minus a square y, when it comes to this side it will become plus a square y will be equal to 0. Now I have already found y1 of 0, I would need to find y2 of 0. So now what I will do again, put x is equal to 0 again here, put x is equal to 0, so 1 minus 0 square, so that is 1 minus 0 square is 0 into y2, this term will completely become 0 because it is minus 0 into y1, that will become 0 plus a square y will be equal to, a square y will be equal to 0, which implies 1 into y2 will be, y2 will be equal to minus a square y, right, minus a square y, which implies y2 of 0, y2 of 0 is nothing but minus a square into y of 0. What is y? Y is nothing but sine into a sine inverse x, so that will be equal to minus a square into sine of a sine inverse 0. In place of x I am substituting 0. Sine inverse 0 is 0 itself, so that is a into 0 will become 0. So sine of 0 is 0, 0 into a square will become 0 again, so which means y2 of 0 is nothing but 0 only. So y2 of 0 will be 0. Now y1 of 0 we have a, and y2 of 0 is nothing but 0. So this we will make use of this y1 of 0 and y2 of 0, and then we will try to find the nth derivative yn of 0. Now so we have already proved in our previous video that 1 minus x square into yn plus 2 minus 2n plus 1 into x of yn plus 1 minus n square minus a square yn equal to 0 we have already proved. Now in order to get the yn of 0, right, we have to put x equal to 0. So let's put x equal to 0 in the above equation. Let me call it as equation number 1. So what happens? So this will become 1 minus 0 into yn plus 2, right, minus 2n plus 1 into 0. So this term will completely become 0 because 0 into anything will become 0, minus n square minus a square into yn, right, yn will become 0. This implies that yn, 1 minus 0 is nothing but 1 itself, so this is yn plus 2 of 0, right, yn plus 2 of 0, this term will completely become 0, minus n square minus a square, when I move to that side this will become plus n square minus a square into yn plus 2 of 0 will become n square minus a square into yn. So this term we will make use, and we will try to find yn of 0. Okay, so now see, we now got yn plus 2 of 0 equal to n square minus a square into yn. So now in order to get yn of 0, what I will do, so replacing n by n minus 2 in equation number 2. So what happens here, so we need yn of 0, we have yn plus 2 of 0 equal to n square minus a square into yn. So in order to get yn of 0, what we will do, we will replace n by n minus 2 in this above equation. So what happens, so yn plus 2 is there, we will replace n by n minus 2, n minus 2 plus 2 will become minus 2 and plus 2 will be getting cancelled, so this will become yn of 0, right, and this will become yn of 0 will be equal to n square minus a square into yn is there, so this will become n minus 2 the whole square, so that is n minus 2 the whole square minus a square into yn of n is replaced by n minus 2, so this will become n is replaced by n minus 2, so it will become yn minus 2. Okay, so let's call it as equation number 3. Okay, so when we were doing yn of 0, when we are trying, we are getting n minus 2 the whole square minus a square into yn minus 2. Okay, so now we have to take the yn minus 2 of 0, right? We have to take yn minus 2 of 0. So now what we will do, replace n by n minus 4, okay, in equation number 2, that is in this equation. Initially we did replace n by n minus 2, now we are replacing n by n minus 4 in 2 again, the same equation. So what happens, so yn plus 2 is there, so n is replaced by n minus 4, yn minus 4 plus 2, n minus 4 plus 2 will become minus 2, so that will be yn minus 2 of 0 will be equal to, okay, so that will be equal to, okay, so yn minus 2 of 0 will be equal to, so we are replacing n by n minus 4 in equation number 2, so this will be n square is there, so that will become n minus 4 the whole square minus a square into yn minus of 4. Okay, call it as equation number 4. Now compare the equations 2, 3 and 4. See, whenever the equation yn plus 2 of 0 is there, we see that n square minus a square into yn. So y2, when we just take y2 of 0, it will become n square minus a square into y0. If we take y3, it will become 3 square minus a square into y0. y4, 4 square minus a square, 5 square minus a square, and so on, right? So see, if you see equation number 3 and 4, let's replace this yn minus 2 of 0 in equation number 4 in 3. So that implies, so yn of 0 will be equal to, see here, n minus 2 the whole square minus a square into yn minus 2 of 0 is there. Yn minus 2 of 0 from equation number 4 will become n minus 4 the whole square minus a square into yn minus 4 of 0. Okay, and so on. If we just find what is yn minus 4, that is replacing n by n minus 6, so this will become n minus 6 the whole square minus a square into yn minus 6 of 0. Again replace n by n minus 8, so it will become n minus 8 the whole square, and so on it will go. So if we observe here, we are replacing every time n minus 2, n minus 4, n minus 6, so we are taking the difference of 2. So we have to get the last term in order to find the yn of 0 here, right? So what happens, yn of 0 can be n minus 2 the whole square minus a square into n minus 4 the whole square minus a square, and so on and so on. It can go till the last term, that is y1 of 0 or y2 of 0. See, when n is an even number, so assume when n is an even number, so suppose if it is 10 minus, it will become 8, right? 8 minus 2, that is 10 minus 2, 10 minus 4, 10 minus 6, right? 10 minus 8, and so 10 minus 8, when it comes, it will become 2. We cannot go for 10 minus n cannot be 0, right? So it can go till n minus 0. So how do we find the last term? So in order to find the last term, we need to put n equal to 1 when n is odd, okay, and when n is even, we need to put n equal to 2 in the equation number 2, the same equation number which we used to find yn of 0. Okay, now let's try to replace n equal to 1 in equation number 2. What happens, it is yn plus 2, so it is y1 plus 2, that will become y3 of 0. Okay, so that will be equal to y3 of 0 will be equal to 1 square minus a square, that will become 1 square minus a square into yn, right? Yn is y1, so that will be equal to y1. So we already found y1 of 0, right? What is y1 of 0? We already found y1 of 0 as a, right? So that will be equal to 1 square minus a square into a. So this will be the last term when n equal to n is even, right? That is sorry when n is odd, and when n is odd we have to replace n by 1. Okay, now put n equal to 2 when n is even to find the last term. Okay, this is the last term when n is odd. Okay, now in order to find the last term when n is even, we need to put n equal to 2 in same equation number 2. So what happens, see here, so y 2 plus 2, so n is 2, 2 plus 2 will become y4 of 0 will be equal to n square, so 2 square minus a square into y2, right? So that will be y4 of 0, that is y2 plus 2 of 0 will be equal to, same thing, here only I am replacing, n square will become 2 square minus a square into, okay, yn means that is y2 of 0. We deduce that y2 of 0 is 0, right? So y2 of 0 will become 0, so what happens, y4 of 0 will become 0. Okay, so from here we can observe that whenever n is odd, the last term will be 1 square minus a square into a, so this will be the last term and it will stop. Okay, and the series stop here. But when n is even, what happens, the last term will go till y2 of 0, which is 0. Okay, so when it becomes y2 of 0, all the terms before that will become 0. So you observe here, yn of 0 is nothing but n minus 2 square minus a square, n minus 4 square minus a square, n minus 6 square minus a square, and so on. It will become 1 square minus a square when n is odd, and when n is even, it will become 2 square minus a square, right? So remember that whenever n is odd, we need to put n equal to 1 to find the last term, and when n is even, we need to put n equal to 2 to find the last term. So what happens, when we saw that when n equal to 2, y4 of 0, the last term will become 0, means the complete series will become 0, right? And when n equal to 1, we will have 1 square minus a square into a. So now replace y3 of 0 in this yn. So what happens, therefore yn of 0 will be equal to, what happens, n minus 2 square minus a square, n minus 2 square minus a square into n minus 4 whole square minus a square into, and so on. So last term will be 1 square minus a square, right? 1 square minus a square into a. Okay, that is when n is odd. Okay, when n is odd. But when n is even, what happens, so these terms into 0, so that will become 0 completely. So when n is even. Okay, so therefore this is the yn of 0, that is nth differential coefficient of the nth derivative. Yn of 0 is nothing but this one. When n is odd, it is n minus 2 the whole square minus a square into so on, and the last time is 1 square minus a square into a, and 0 when n is even. Thank you for watching, and please let me know if you have any questions and queries, or on which topic you want me to make the video, and please subscribe. Thank you.